Hi guys, welcome to what should be the final software update for the Freedom Platform project. I hope it is. I've had a ball continuing to work on the software, but I think it's become a bit too much for the channel some time ago. I've already uploaded a sneak peek at the analog level meters. This can be achieved because the VS1003B chip answers requests for DAC sample values. This is a legitimate stereo display, unlike the spectrum analyzer, and unlike the spectrum analyzer, the DS-PIC does most of the work for this display. It has to send requests often and calculate averages for the needle positions. The ghosting effect you see there, it could be avoided. I lost accuracy though when I tried to simulate the needle spring. I had to choose between one or the other, and this one looked more realistic overall. And of course, what motivated me for all this extra software work was the free trial optimization, which I've taken advantage of now, and my trial license has almost expired. Pay attention to the day in the date, which is about to roll over with the same odometer effect as the time. I wasn't able to achieve this until I drew it somewhere else on the screen and then blitted it back to its final location. One way to move an object on a screen from one location to another is to increment a value and use that as the X or Y coordinate. Another way would be to take that value that you're incrementing and use it as an index for a lookup table so that the final position could be anywhere. And that way I've been able to achieve a cheap hack physics spring effect for the menu. You could say that I was inspired by a particular fruit company product's GUI, and that's probably true. I'm no fanboy anymore, but there are definitely aspects to the hardware and software of that company's product that I always have and will continue to admire, until they've gotten rid of the last of them over the next few updates. This is a version of the original IBM CGA font modified by a chap called Anarchy, and then a little further again by myself. Defining this in binary wasn't fun. Looking here carefully at the January, you'll see that because of the differences in width of different characters, there are differences in the width of the spaces between characters, such as the U and the A in January. This is a variable width font, so for a function like draw text string centered to exist, you have to first pretend to draw a string to the screen while you're just really measuring it, and then find what will be the center position on the screen and then really draw it. Now, if you've seen the previous videos with the previous font, this is the first one with the new one. Yeah, I'm sure you'll agree it was all worth it. I've cheated a little bit here and I'm only using the uppercase characters, digits and some symbols. For the first font though, the HD 44780 font, every printable ASCII character is defined, so that includes lowercase and all symbols defined on the ASCII table. It so happens though that there's no case where any of this software will ever print lowercase characters. Tetris is a little bit fancier with the rounded borders and the new font for the score. There are a few other touches that I won't show here. The last parts have arrived. These are the dual FETs in one package for the soft power switch, so I really am going to try to get this done in hardware terms. The prototype sent off to the PCB designers this week. For the next feature I wanted a little smoother movement, so I've incremented an X coordinate across an axis in 24 steps. The bottom one moves in linear increments while the top one has the lookup table applied to it. Audio from the device itself is largely disabled for this video, but the sound effects are all there. It was just because I knew I was going to speak in this video. So the large digits you see there is of course the new font, and it's scaled up to double the size in exactly the same way that the old one was. This is the only program that does that. The new font was easy to implement in this program. The text is the same height and all of the digits are the same width as each other for this font, even though they are one wider than the last one. There was only slight adjustment to the odometer effect and the display to fit this in. The messaging system is different. All of the messages slide in and out. You could say that the waiting for GPS message is a little different from all the others. It has an authority, say it can enter any time instantly as it loses a GPS fix. The moon phase spoken in English expression is new, so from the moon percentage illumination alone, you can't tell if the moon is on the way in or out, so now you can. Vector mapping GPS. I've done a previous video about a clipping box or bounding box, they might be so called, regarding a rotating GPS map, a track up display that rotates to orient itself with the direction of travel. An idea is to use a bounding box so as to exclude drawing anything that you don't have to speed things up. So the previous video was about a static bounding box, wide enough to make sure that everything that could be on the screen at any angle of rotation is drawn. There's a slight bug in this animation on the left x-axis. It has the wrong sign, so down the bottom left, the x there at the moment should be -7. There are a few ways that I've sped up the GPS map render. The track up mode will never be as fast as the north up mode because you still have point rotation. One of the ways was a change to the map file format, so there's actually less overall reading from the SD card. And the major update here is a dynamic clipping box. So given the current angle of rotation, the clipping box will be as narrow as it can be in either direction to make sure that the least is drawn as possible, speeding up the map render further. I say the least is drawn, but in track up mode, every point that's drawn has to also be rotated, and I think that's where the expense in CPU time is. This screenshot was a test of the dynamic clipping box function, narrowing the box by 11 pixels for each frame just to see that it was close to the edge. This video segment is being played in real time, so this is as fast as the GPS will render a large city map at low zoom where there are the most points to draw. In normal use you'd be closer, it would be faster. My real GPS coordinates have been offset with a couple of random numbers right in the GPS routine so as to hide my real location. The same for the clock program, my real location could be reversed from that data. So for the map, of course, I had to keep those numbers small enough to keep me in the same city so I could show you this map sniffer feature, which will show you the nearest road or trail depending on the type of map loaded, and the nearest point, and your bearing and distance to both of them. If we were zoomed in closer, these points that are flashing would be further apart and look nicer. This feature is triggered when you exit GPS mode into map browse mode, which is essentially, for practical use, pausing the GPS mode if you were having a rest. This isn't the first time I've implemented this feature. A GPS program I previously wrote for the App Store would constantly indicate your nearest road, point of interest and trail because the platform was fast enough to calculate this every time on the fly for every frame. It's what I considered the prime feature of that program, to have that information at your fingertips all the time. For the PCB guys, yeah, I have kicked into hardware again. These are the battery holders being glued together, ready to be mounted on the board. Brandon mentioned he wanted to use a phone battery, which is fine. Go ahead, do what you want. I just want to make sure that I send a working unit, but I'm not trying to dictate how the project is done. I wouldn't have used 18650 batteries myself, to be honest. It's what I thought everyone else would do. I'm testing a serial terminal debug output mode here, so if the unit is configured that way in its SD card configuration file to output errors, it will output errors that I use during development. It will output live as any errors happen, and then anytime you exit a program back to the menu, you'll get a message which will be okay if there were no errors during the session. Some of these are just idiot errors, like there was no music folder and you tried to play music. The list of error codes is comprehensive for what the project actually is, but I'm very confident about it. Some of these I'm confident can and never appear. There's an option to print these to the screen, which works in a similar fashion to the frame counter. Some jazzed up graphics transitions for the secret configuration override function at runtime. So if you want to just bypass some configuration setting for one session, it's easy to do here for some options. Secret menu, it's still called that somewhere in source. I guess the secret's out, I'm making a video about it. To activate the secret runtime configuration override menu, hold joystick left from startup. I just overrode the cover show feature so I don't have to wait for JPEG cover art to load. That's it, so hopefully I'll catch up with you guys again this week, and hopefully that contributes to cleaning up my immediate project test area, which has been a mess for way too long and I don't get to use it. Okay, I hope you enjoyed that. Catch you later.